Hello, everybody, and welcome to City Lab's webinar, Working as a Team. My name is Keith Hanglin. I'm Regional Director for City Labs North America. I'm joined today by Colby Brown, Training and Services Director for City Labs. The idea behind today's presentation is to give you a look at new technology from City Labs called Sugar and some of the integration that ties it into the Cube transportation modeling platform. Get my slideshow started up here. So before we begin, it would be worthwhile to go through and discuss the teams and just how transportation and GIS come together. As we see it, it's a tremendous opportunity for both communities. So let's take a look at the communities. On the one side, you have the GIS community. It's an enormous user community. They're highly integrated with IT resources, and they deal with many different kinds of subject matter. In the transportation business, we'd like to be able to better leverage this subject matter as it relates to our business practices. I think one of the notes to make about GIS practitioners is that they're primarily focused on the present and historical conditions. With modeling, it's good to leverage these present conditions so that we can better understand what's going on today in order to model the future. So on the modeling side, we have primarily Cube users. They're more specialized in their work. They have highly developed methods and analysis tools for different types of transportation and forecasting needs. The key is their models are designed to forecast conditions based on rational decision making. In other words, we're trying to represent as a modeler the behaviors of people as they interact in a region, commute to work, or make decisions about where they locate the land use site. So the idea for today is to actually talk more in detail about these two teams and how we interact together, and how technology from City Labs can help make that possible. I think it's important to first understand what these processes are and where the data comes from. So you'll see on the left side of this slide, I have the typical modeling workflow. You have data describing a scenario fed into a travel model, and it creates different data files and results describing those scenarios. Ideally, we want this data to come from a regional geodatabase, and in many cases it already does. So when we add the GIS side into the equation, we have these regional geodatabases, different conversion programs that are typically required to get data into these describing scenarios. And once our data is created out of the model, we have to get these results back into the regional database using different conversion techniques. We see these mismatches in technology and data compatibility as impediments to the overall process. Anytime we need to convert data or process data or take it from one file format to another, it takes time and costs money. So City Labs is working to make this process more efficient. I think another thing to understand is that there's lots of people involved in the modeling process that require information from us. So we have our management that sends requests into this modeling and GIS process. We in turn feed data back. But of course, it usually takes some processing, and sometimes these technology impediments get in the way. Management then feeds this data back to the stakeholders involved in these various projects. There's also folks on the engineering, planning, and other agencies that need the same information to do their work. So there's a lot of interaction going on here between different data resources and getting things from one point to the next. So let's take a look at what we're trying to work towards. We have our traditional model showing the model process and the data process. If we can eliminate some of those conversion utilities and eliminate some of the technology barriers, we can have these models directly feeding off the regional ESRI geodatabase. With our engineering, planning, and other agencies also having better tools to connect into these databases, we can have more of a seamless process for putting together, processing, and understanding the knowledge about our communities. City Labs products all store data in ESRI geodatabase format. So with an understanding of the workflow and what we're trying to get to here, It'd be worthwhile to take a look quickly at the technologies involved. So on the modeling side, we have Cube. Cube is a modular system for transportation analysis tools. All kinds of tools are developed as modules to plug into our Cube environment. It contains several model libraries and extensions. All these are designed to solve all kinds of transportation-related problems. So we have things like Cube-Base, which is the core platform and user interface. Then we have the traditional passenger demand model. These are the two pieces we'll be looking at today. We won't be looking at all our capabilities. But I encourage you to take a look at our website and learn more about things like avenue traffic simulation or cluster multiprocessor optimization and the other tools that are out there. What's nice about Cube, it's actually a scalable framework. It allows model builders to build models and model end users or appliers to use these models. So it's a really nice framework, not only for building models, but for distributing them to different model users in our organization. And now it contains key components for ArcGIS for seamless data integration, map creation, and reporting. Just a quick review. I know many of you are Cube users out there, but we want to introduce some of our GIS folks to the capabilities handled by Cube. So this is a look at the Cube-based user interface. All the model libraries plug into this for access. The application manager is key for model builders and also used to a lesser extent by the model appliers for looking at the application workflow and logic and the different data sources and how they plug together and what operations are run on them. There's also a table window. This allows us to look at any tabular information. In this particular window, you're seeing trip matrices all nested nicely in the window, so I can quickly go from one to the next. And then a very powerful ArcGIS-based GIS window. This is built with ArcEngine for seamless compatibility with your broader ArcGIS framework. And finally, a key component of the modeling process is scenario and data management. So we have this utility called the Scenario Manager, which is really designed to manage lots of different data, lots of different application tools, and the different scenarios that I might run or test with my model. So in this case, you see a base year scenario, then I have a growth scenario with some children off them, giving different alternatives to the growth scenario. Because the Cube user interface is so well laid out, it's very easy to navigate between different scenarios, data resources, and application tools. So let's take a look at this new product called the Sugar Network Editor. This is really designed for GIS professionals and ArcGIS users. It's built as an ESRI ArcMap extension. So you install this along with ArcMap, and they work hand in hand. It's designed for creating and maintaining transport network data using traditional standard GIS techniques. So anyone that uses ArcMap will be pretty familiar with some of the tools in here. It also has customizations to help make transportation network management very easy. And it supports both transportation and GIS professionals alike. And what's nice about Sugar, it's built on the Cube database framework and supports other things like ArcGIS Network Analyst or any other capabilities you have in your GIS shop. So let's take a look at the Sugar user interface. The first thing you'll notice when you install Sugar is that there's a menu. The menu is used to access the major components of the extension. Opening the Data Manager, you'll be able to manage your data files, do things like routine data processing such as importing and exporting, and also merging tables or creating joins. The Feature Explorer is a network editing utility, really designed to manage line directionality, junctions and link node topology, also to do your transit editing. There's also a window in here for anything that's selected to review the attributes and update them effectively. The Junction Manager is designed specifically for intersection management. It has lots of features in there, such as managing signal phasing and turn movements. It also has windows for attribution, setting the type of signal, and managing approach, movement, and things like penalties and volumes collected in the field. And finally, there's a series of toolbars, 3 in total, one for starting and stopping editing, another for doing network edits to highway and transit and pedestrian networks, and a third for transit. So it's enough talk. Let's go into the demonstrations. For today's purposes, we're going to walk you through 2 demonstrations. The first one is a base year calibration project. For the modelers out there, we know calibration is always a difficult task, and sometimes we put them off for a number of years. We'd like to see the modeling community taking on these calibration by leveraging GIS resources to simplify the overall process. So I'm going to open ArcMap here, and you'll notice it's a standard ArcMap view. I have my sugar menu item at the top, and my toolbars, which are showing here, are disabled now. This is the public transit toolbar, the network editing toolbar, the start and step editing toolbar. I'm going to go ahead and open the Data Manager. The Data Manager is designed to manage all the information I need to perform my work. As I get new resources, I can add them in as I need using this Add Data button. I can also create new databases, which I demoed a few weeks ago during another webinar called Discover Sugar Network Editor. For those of you wanting a more detailed look at the tools and functionality of Sugar, you should definitely go to our website and take a look at that webinar. So in here, I have my model database. It's called CubeTown. And then I also have a working directory storing files that I'm going to be using throughout this demonstration. Both of these allow me very efficient and easy access to my data resources. For this demonstration, I'm going to walk you through 3 steps that Colby has asked me to perform to support his model calibration project. One of them is to get an updated land use file ready for the new calibration. The other is collecting streamline counts from my traffic engineers. And then to map out these changes in data so he can easily see them and compare them with his model results. So the first thing I'll do is add my new land use data to my table of contents. This data, you'll notice, is a shapefile that's stored in my file system. I could have pulled in parcel data and processed this data, or in this case, I probably worked closely with my land use planners to determine which areas had grown and actually reflect those in the database. So if I open up the attribute table here, you'll see that I have all the fields necessary to support my model. In this case, that data is already set up to support the modeling process. I'm not going to go and change the base year land use without Colby checking this one first. So I'm going to use our import utility. And I'm going to select to import this shapefile into the model for Colby to access directly. There's really no need for us to trade these shapefiles back and forth when I can go directly into the database with this utility and make the update. So you notice I've set my input data set and my output database. I could put this in a featured data set, but for my purposes, I'm just going to add it as a standalone feature class. I'm going to make sure it has a spatial reference. And I can go ahead and import that from my existing CubeTown database.